Hi everyone, my name is Brock Gilman and this is my presentation on sorting in data structures and algorithms. I'll be giving a brief overview of what sorting is, walking through several key algorithms and ending with a summary of their use cases. So without further ado, let's go ahead and get started. So what is sorting? Sorting is the process of arranging data in a particular order, usually ascending or descending. It's one of the most basic and important operations in computer science, helping with tasks like searching, organizing data, and optimizing performance and other algorithms. As you can see here, this is a unsorted list compared to its sorted list in ascending order. Here's a quick comparison of time and space complexities for common sorting algorithms. You can see that some, like selection, bubble, and insertion, have poor worst case performance, while others like heap, quick, and merge sort are more efficient for larger data sets. Selection sort, first up, basically works by selecting the smallest element from the unsorted part and moving it to the sorted portion. It repeats this process until the array is sorted and is simple but inefficient for large data sets due to its O of n squared time complexity. So as you can see, it identifies the minimum element in the unsorted portion. This is the sorted portion. Swaps and repeats until only one element remains in this sorted section over here. Up next, we have bubble sort. Bubble sort compares adjacent elements and swaps them if they're out of order. Essentially in the name, it continues to bubble up the largest values to the end. Like selection sort, it's mainly useful for educational purposes. So as you can see here, it's making its adjacent comparisons and swapping it in its correct order, or in other words, bubbles up. Next, we have insertion sort. It builds the sorted list one element at a time. So it's efficient when dealing with small or nearly stored data, and it's stable and in place, making it practical in some real-world scenarios. Again, it picks the first element from the unsorted section, inserts it into the correct position within the sorted section by shifting, and then repeats until all are sorted. Up next, we have heap sort. It builds a max heap and repeatedly removes the largest element, placing it at the end. It's efficient and uses O of 1 space, but it's not stable and can be slower than quicksort in practice. As you can see here, it builds a max heap from the unsorted array O of n time complexity, swaps the root or maximum element with the last element and reduces the heap size. And then we perform a function called heapify, which is performed on root to restore the max heap property and repeats until the array is sorted. Next, we have quicksort. Quicksort is a divide and conquer algorithm. It picks a pivot, partitions the array around it, and recursively sorts the partitions. It's usually the fastest in practice, but has a worst case of O of n squared if the pivot are poor choices. So as you can see here, we can have the pivot be any choice, typically first, last, random, or median. In this case, it was median. Next, we have merge sort. It's also a divide and conquer scheme algorithm, but it splits the array in half, sorts each half, and then merges it back together. It's stable and has consistent n log n performance, making it great for linked lists or stable sorting needs. So here's a quick summary of the best use cases. Selection and bubble sort are good for small or educational scenarios. Insertion works well on nearly sorted data. Heap is memory efficient. Quick is fast on average, and merge is stable and predictable. Some final thoughts. Sorting is, once again, a foundational concept. Knowing the trade-offs between algorithms helps in choosing the best one for your use case. It also builds your understanding of complexity and recursion, which, again, are key to more advanced topics in DSA. That wraps up my presentation. Thank you so much for listening. I really appreciate it. Reach out if you have any questions, and I hope you have a great day.